Hello, my dear students. I hope you're all doing well. My name is Benatang Paton, and I welcome you all to the channel Classroom, where we learn together. So, my dear students, in today's class, we will be learning about image formation cases for concave mirrors. A very important topic, plus a very easy topic. But mind you that in order to master these image formation cases, you need to first know the different rules which we have studied in the previous class. So in the last video which was uploaded, here we have discussed about the rules for drawing ray diagrams. Altogether there are 4 rules, and each of these rules you have to know, because these image formation cases for mirrors, whether for concave mirror or convex mirror, we use those rules only. So if you have not watched the video and if you're not thorough with that, I will sincerely request you to pause the video, go back and watch the video, and then come back, okay, with the understanding of the different rules. And if you know the rules, this easy, okay, this is a piece of cake if you know the rules. So assuming that you have mastered the rules for drawing ray diagram, without wasting further time, let's jump to the lesson and let's learn together. So I will be holding my marker, and what should you be holding? You should be holding a pen or a pencil, and besides you there should be a notebook, and then you should be copying down whatever we discuss here in the whiteboard. Now this way, okay, this way I can help you, and this way you will score better in exam, and your understanding of science will be much better. See, that's it, okay, your understanding of science will be much better. So this is one simple step which you can follow to learn, okay, whenever you're watching any video from YouTube, if it is educational, or yeah, if you're watching anything of interest, make sure that you take down notes. All right, so let's develop this good habit of taking down notes. Okay, so enough of talking, let's go to the lesson and let's start our class. I might have filled these markers with lots of ink. I have just refilled it before the class, and then maybe I must have refilled some markers with lots of ink. All right, this looks all right. So there are 6 cases, so we'll start with case 1. Now in each of the cases we will be studying 4 things: object position, image position, size, and nature. All right, so let's start with case 1. So case 1, let's divide this, let me divide this wire, this space for writing into 2 parts. So which is the middle? What would be the middle here? Is this the middle? Okay, let me just break it from here. All right, now let us start with case 1. Now 4 things we'll be writing: object position, image position, and size and nature. So let's start with object position. So object position. What do you mean by object position? My dear students, object position means where the object is kept. All right, that will be object position. So object position simply means the position of the object with respect to the mirror. That is called object position. All right, then we'll be writing the image position also. Then what could be image position? Image position here refers to the position of the image with respect to the mirror. Where is the image formed? And let me remind you, my dear students, that to study the image, we study the reflected rays. All right, we study the reflected rays at the point or at the place where 2 reflected rays meet. That is where the image is formed. Okay, so please remember that to study the image, we will have to study the reflected rays, not the incident rays, but we study the reflected rays. And at the very point where they meet, okay, where they intersect each other, that is where the image is formed. Okay, please remember that. Then next is size. Size here refers to the size of the image, which I will elaborate once we draw the ray diagrams. Then we have finally the nature. So nature, well, For concave mirror will give you real images, and if the image is real, then my dear students, remember that the image is inverted. So concave mirror, for most of the cases, it will give you real image. Since it will be a real image, the image will be inverted. But then there's a twist at the end of the, okay, there is a twist. There will be a twist, and I will not tell you which case it is, but there is a twist. So not all the cases will give you a real inverted image. There is one particular case which is going to be tricky here. So let's study the cases one by one, and let's find out in which particular case this this in which particular case the image form is different. Okay, so concave mirror, usually it forms real and inverted image. So let's see which case it is, okay, where we get a different kind of image, which is virtual, and okay, I'll tell you later. So nature, we'll have to discuss that. Okay, now let's draw the ray diagram. Let's draw the ray diagram. So draw a concave mirror. This is a concave mirror. Demarcate the non-polished part. It's a concave mirror, so the polished part is the curvy part. Okay, so the curved part is the polished part. Then we'll have to mark the pole. So mark the pole bigger like this. Write P for pole. Then draw the principal axis. Draw the principal axis through the pole. So let's say this is the principal axis. Now, in case 1, where could the object be? In case 1, my dear students, the object will be at infinity. Okay, we start this amazing story, okay, by keeping the object at infinity. So in case 1, the object is at infinity. Now let me break it down, okay, in advance, where the objects will be in each of the different cases. So in case 1, you have to remember that the object is at infinity. So since the object is at infinity, we will not be drawing the object. So I will not be drawing the object. But then remember this, that if the object is at infinity, we will be taking two parallel lines, okay, two parallel rays of light from the object. So the object will be at infinity, but then we will be considering two parallel lines, two parallel rays, which will be the incident ray. It is called the incident ray because it is coming from the object. So two parallel incident rays will be considered. Now we will be considering two incident rays for every cases. For each and every case, we will be considering just two rays. Okay, we can take 3, 4 also, but then 2 is enough. With 2 we can study. Okay, so we will be taking only 2 rays. So we will always be considering 2 rays, not more than 2. So in case 1, the object will be at infinity. Okay, then at case 2, the object will be finally revealed, so we will be able to see the object. So what the object will be? What type of object will we be drawing? We will be drawing a simple arrowhead. Okay, this will be our object. So this will be our object for all the cases. This will be our object, and since the object is this arrowhead, even the image will be an arrowhead. And then if it is real image, then it will be an inverted image. If it is a virtual image, then it will be an erect image. I hope that's clear. Now, the object in case 1 is at infinity, so we will not be able to see the object, but the object at case 2. Now, you know that on the principal axis, we have to mark the center of curvature and the focus. So let's say this is the center of curvature. So the distance from C till P, the distance from C to P, that means this line from C till P. What is that called, class? Anyone who will tell me what is the length of this line from C to P called? Yes, what is that called? Correct, it's called the radius of curvature. So C to P, the length of this line from C to P or P to C is called the radius of curvature. Now exactly the half of radius of curvature, which will be here for me. What is this? What is the name of this dot? What is the name of this dot? Yes, this is called focus. Okay, and then what is the name? What is the length? Okay, the length of the line from F to P or from P to F. What is it called? What is it called? Yes, I don't know. Somebody please tell me what is it called? The length of the line from P to F. Correct. It's called the focal length. Okay. So remember, this is focal length, and then from here till here is called the radius of curvature. Correct. And at exactly half of radius of curvature will be our focus, and the distance, the length of the distance, the length of the line from P to F or F to P is called focal length. See, it's this easy. Okay. Now the object is at, okay, yes, so what I was telling you, yes, I was telling you where the objects will be in all the different cases. So in case 1 the object is in infinity, in case 2 the object will be exactly behind C, so the object will be drawing here in case 2. Then in case 3 the object will stand at C. In case 4 the object will be between C and F. In case 5 the object will be at F. In case 6 the object will be between F and P. So these are the different positions of the image which we will be studying in all the different cases. In simple, try to understand this, my dear students, that the object, okay, the object is trying to get closer to the pole of the mirror. All right, I repeat, the object is trying to get closer to the pole of the mirror. So in case 1, the object is nowhere to be seen. In case 2, finally the object reveals itself, which is behind C. In case 3, at C. In case 4, between C and F. In case 5, at F. And finally in case 6, between F and P. Well, the object cannot be kept at P because pole is in the mirror. So we cannot keep the object in the mirror, isn't it? So the object can be here, it can be here, it can be here. Okay, so it can be anywhere in between F and P. Similarly, when I say between F and C, doesn't mean that it has to be always here. No, it can be here also, it can be here also. It can be anywhere as long as it is between C and F. And beyond C, that means it can be anywhere beyond C. Okay, it can be here also, it can be here also, it can be here also, but it should not go, okay, it should not touch C. So anything, anywhere here will be correct. All right. So having said that, let's draw the ray diagram for case 1. So in case 1, the object is in infinity, so we will not be drawing the object. But remember, whenever the object is kept in infinity, 2 parallel beams of light will be considered. This is how we study case 1. So let's draw the first incident ray, which is coming parallel to the principal axis from the object which is kept at infinity. So let us say this is the ray, incident ray. Then this is the incident ray coming, traveling parallel to the principal axis. Which rule is this? Can anybody tell me which rule is this? In which rule is the incident ray traveling parallel to the principal axis? Correct, rule 1. Then, after reflection, how will this incident ray pass? Yes, it will pass through focus. So it will pass through focus. So this arrow, okay, this arrow indicates the direction of the reflected ray, and the reflected ray passes through the focus from this point of incidence. Okay, so at this point, reflection starts at this point. Okay, for the incident ray, this is the point of incidence, and for the reflected ray, this is where the reflection will start. Then let's draw the second ray, which will be this. So this is the second incident ray, and the incident ray is traveling parallel to the principal axis. So following rule 1, after reflection it will pass through focus. So this is how it will be. So this is the reflected ray, this is the incident ray. Now this is the first reflected ray. Look at this journey, it's going like this, passing through focus. And this is the second reflected ray, and look at the reflected ray, it's passing through the focus too. Where do the 2 reflected rays meet? Look into the ray diagram and tell me, where do the 2 reflected rays meet? Yes, they meet here, isn't it? They meet here at focus. So image position, what do I write at image position? For image position, I will write at focus. So here the image is from at focus, so image position at focus. Okay, oh yes, I have not filled up this one now. So object position, I will write the position of the object here. So where is the object kept in case 1? The object is kept at infinity. Look, okay, my dear students, I have not drawn the object. The object is at infinity. So the object is infinity. So I'll write at infinity. Now, size of the image. The image is from here. Okay, the image is from here. This is a dot. This is a dot. Okay, it's a point size. It's point size. So the image from here, the image from at focus is called point size. So size of the image, point sized. This is what is mentioned in the textbook also. Then nature it will be real and inverted. See, if the image is formed on the same side as the object, it will be called real. The object is kept here. Though the object is in infinity, my dear student, the object is here. Okay, so the object is on the left side. Okay, and remember, object is always kept on the left side of the mirror. So the image is also from here on the left side. The image is from here. Is this point not on the left side of the mirror? The mirror is here. So is it not on the left side of the mirror? Yes, this point is on the left side of the mirror. So the image is formed on the same side where we have kept the object. So such type of images in with respect to mirrors are called real images. Okay, so the image will be real. Okay, then now you also remember that if it is real, then it will always be inverted. So it will be real and inverted. All right, so this is case 1. Easy? Yes. Okay, it's very easy. Now let's go to case 2. So case 2, object position, then image position, then size, and finally nature. So we have to draw the ray diagram. So let's draw the concave mirror. Let's draw the principal axis. Let's mark this pole. Let's show the back side of the mirror, the unpolished part, which is the back side. Let's mark now for this ray diagram. I will start with the focus. So let me show you the focus. Now what I will do is I will measure the distance between P and F, which is this, and without altering this, I'll keep one of my finger at F, and then I'll make a mark here, and this becomes my C, which is the center of curvature. You need to remember the relationship between R and F. The distance from here, from this C till P, is called R, which is radius of curvature, and focus is a point at half, okay, at half of R. So the distance between P and F, okay, is half of the distance between C and P. Okay, F is half of R, and R is twice of F. Okay, good. Now so let's write down. Now for this is case 2. So the object will finally be visible. So we will be drawing the object. But remember, the object will gradually, okay, proceed towards the pole of the mirror. So where will the object be? Yes, the object will be here, okay, behind C, okay, or we can say beyond C, okay, because see, beyond C. Why? Because we always start our measurement from here. So measurement is started from here. So basically that means I should be here. Okay, I should be here on the pole. So measurement, we are looking from here to there. Okay, we are looking from here to there. So if I look from here to there, and if this is the object, I'm standing here, then how do I call this? Is it not beyond C? I have to go more than C, is not, to reach the object. So can I say beyond C? Yes, I can say beyond C. That means it's beyond C. I have to cross C to reach the object. Or I can also say it's behind C. Okay, both works. Beyond C or behind C. Okay, so this is called beyond C. So let's draw the object here. This is beyond C. So object position is beyond C. Okay, beyond C. Not the singer Beyonce. Okay. Okay, not funny, nah? Not funny. Okay. Please don't mind. Excuse me. Now, so the object is kept beyond C. So now Now this is where students make mistake. Okay, I have seen my own students inside the classroom make this mistake, so I don't want you to make the mistake. Now here the object is, this is the object. We will be drawing how many rays of light? Yes, we'll be drawing 2 rays of light. Okay, we'll be drawing 2 light rays. And remember this, okay, the easiest way to tell you is that, see, my feet are touching the ground and my head is upside. For this arrow, this is the head and this is the foot. So remember, the light rays that we will be drawing will be from the head. We'll be drawing from the head. This is called the arrowhead. Okay, every arrow has got a head like this. Arrows are drawn like this. So this part is called the head. This part is called the head. This part is called the head. Okay, so this is the arrow. So this is the head. And remember, the light rays we will be drawing from the arrowhead. So how are we going to draw? I'll show you. So we will be using rule 1. So let's use rule 1 and draw the incident ray. You know in rule 1 that the incident ray travels parallel to the principal axis. Yes. So following rule 1, this will be the incident ray which is traveling parallel to the principal axis. What happens to the ray which travels parallel to the principal axis? After reflection, it will pass through focus. So this is the point of incidence, and after reflection, it will pass through focus. So it will go like this. Okay. Next, rule 1, we have used rule 1. Now we are not going to use the same rule twice. There are 4 rules. We have used rule 1. Now you can use any of the 3 rules. Now, excuse me, for the second ray, I'll be using rule number 2. Now what does rule number 2 say? Rule number 2 says that the incident ray has to enter through focus. The focus is here, and then I'll be drawing the incident ray from here because this is the head. The rays that we draw from the object will always start from the head. So the incident ray has to enter through focus. So the focus is here, so the incident ray has to enter through focus. Okay, so this is the incident ray which has entered through focus. If the incident ray enters through focus, after reflection, how does the reflected ray go? How does the reflected ray go? The reflected ray goes parallel to the principal axis, isn't it? So the reflected ray will go parallel to the principal axis. So this will go parallel. So this goes parallel like this. Now, let's pay attention to the reflected rays. The first reflected ray is this one. This is the reflected ray. The second reflected ray is this one. So do the 2 reflected rays meet? Does the two reflected ray touch each other? Do they meet? Yes, they meet here, isn't it, at this point. So here the image will be formed. Now, my first question is it a real image? Is it a real image? What did I just say earlier? How do we know that the image is real or not real? If the image is formed on the same side as the object, then it is real image. Object is here. Image will be formed here. So are they on the same side of the object or not? Yes. So it will be a real image. If it is a real image, then will it be erect or inverted? It will be inverted. Okay. Real and inverted. So the image will be a real image, but it will be an inverted image. So how will the image be? The image will be like this. This is the inverted image of the object. The object is an arrowhead, so the image will also be an arrowhead only. All right. If the object is the marker, then the image will also be a marker. Is it not? It cannot be a duster. Understood? The image will be identical to the object. Okay. So let's write down. Let's fill up this one. Object position we have mentioned is beyond C. Image position. Where is the image position? It's between C and F or F and C. Okay. So between F and C, we can also write F and C or C and F. Anyone is correct. Size. Look at the size of the object and look at the size of the image. Can we say that they are of the same size? Absolutely no. They are not of the same size. The image is smaller than the object. So what do we write here? We write here, we don't write smaller, okay? We don't write smaller. As per your textbook, the right word is diminished. So write diminished. Diminished means smaller than the object. And nature will be real and inverted. all real images are inverted. Okay, so this is case 2. Now let's go to case 3. So case 3, let me write 3 here. Okay, now let me just quickly erase this. Okay, these things will have to be, these things have to go, these things will have to go, this will stay, so I'll just keep it like that. And then, or let me just erase it. It's not, why be lazy, nah? So now we'll go to case 3. Case 3, where will the object be? In case 2, the object was here. So where will the object be at case 3? Where will it be? Correct, it will be at C. Okay, it will be at C. So case 3, object position is at C. C stands for center of curvature. Then image position, well, let's find out. Okay, so let me draw the ray diagram. This is the ray diagram. This is the center of curvature. This is what the center of curvature. Now this is the principal axis. Sorry. So this is the pole. This is F, taking the distance, going back. Here C. Now let's draw the ray diagram. So let us draw the object. This is the object. Then use rule 1 here. Then this is rule 1. Incident ray traveling parallel to the principal axis. You can see it's parallel to the principal axis. This is the point of incidence. After reflection, it passes through focus. Okay. Now let's draw the second ray using rule number 2. So rule number 2. Let me just get some idea. Okay, I don't want to make mistake. Okay, somewhere here. So all right, I think this will give me a correct answer. Will I get it? Let's try. So sometimes these ray diagrams, especially this case, okay, case number 3, I'll make a lot of mistake. So please don't mind if it is wrong also. I'll redraw again. I promise you I'll redraw again. So this is the incident ray entering through F, and now it has made contact with the mirror. So here is the point of incidence. Now reflection will take place, so it will reflect, and then it will go like this. Now they meet here, so the image will form here. So the figure will come out like this, and then this becomes a wrong figure. You know why? Because in case 3, the image is formed at C. The image is also formed at C. So we should be getting the image like this here. Mine is a little short. It's a little short. So I have to redraw again. So let me redraw again. Well, it happens, no doubt, it happens. So let me redraw again. This time I'll try my best not to make mistake. So let's do like this. This is the back side. This is the pole, mark it P. Then this is the F now. Let's see, this is the F. So this is the object. Then rule number 1, parallel, it will pass through focus. Then rule number 2. It will enter through focus. Then this will reflect back, it will travel parallel. Yes, and finally they meet here. This is the incident ray, this is the reflected ray, and then they meet here. So they meet here. Yes, so we should be getting some. This is the correct figure for case number 3. It's a little difficult. We need a lot of practice. Okay, so here intentionally I have bended a little bit, but if you're using scale and pencil, then you will get. I'm doing with freehand. Okay, this case is a little difficult with freehand, but some of you are an expert in drawing, so you will be able to get it at one go. Okay, you are that smart, I know, but for me, okay, I will not lie to you, but you can see that Okay, I have intentionally bent it a little bit because I want to get the image here. All right, so I should not have done that, but I did that. Okay, but I'm telling you, if you practice, you'll get it easily with scale and pencil. You will get it at one go. Also. Now, so this is case 3, the ray diagram for case 3. This is an important case, a very important case. Why? Why? Because see here, my dear students, here the image is also from at C. Object is at C, the image is at C. Okay. In most of the cases, you will find that the object position and the image position are not same, but there is one case where the object position and the image position is same, and this is the case. All right. So the image position, it will also be at C. Now, look at the size of the image. Look at the size of the image and compare it with the size of the object. So the object is this. This is the size of the object, and look at the size of the image. What do you say? Can we say it's same, or should we say the image is bigger, or should we say the image is smaller? So is it bigger? Is the image bigger? Is the image smaller, or is the image the same size as the object? Which is it? The image is of the same size as the object, is it not? So here size, okay, same as object. So the image is of the same size as the object. This is why this case is very, very important. This is the only case where the image and the object size, the height of the image and the height of the object are same. The size of the object and the size of the image is same. Okay, so this is the reason why this case is very, very important. Then nature, what will be the nature? This will also be real, and if it is real, then it will be inverted. Okay, so this will be real and inverted. So this is case 3 for us. Now let's go to case 4. So let me erase this object position. We'll have to erase this. Let's erase these things. Let's erase these things. Let's erase these things. Let's also erase the ray diagram. Case 4 now. Case 4. Where will the object be? So let's draw the ray diagram first. Let me show the back side. I have marked the pole. Let this be the focus. Taking the same measurement, I go and mark my center of curvature. So in case 3, where was the object? The object was at C. Now in case 4, where will the object be? Will the object still be at C? No, is it not? The object will move ahead. It will be now in between C and F. So object position between C and F. So we have to draw the object between C and F. So let's draw the object here. Yes, let's draw the object here. The object is between C and F. All right. Now we will be using rule number 1 and rule number 2. In most of the cases, we use rule number 1 and rule number 2 a lot. All right. So rule number 1 we always use. So rule number 1. Incident ray goes parallel to principal axis. After reflection, what happens? Yes, it passes through focus, isn't it? So it will pass through focus. So it will pass through focus like this. So this is the reflected ray. Now let's draw another ray. Let's use rule number 2. Okay. So rule number 2, the incident ray which will emerge from here will enter through focus. So the incident ray will enter through focus. So let's draw that. So then after reflection, this is the incident ray. It has touched the mirror here. So reflection will take place. After reflection, it will go parallel. So where do the two reflected rays meet? This is the first reflected ray. This is the second reflected ray. Okay, the second reflected ray. So this is still the second. This is the second ray, but this ray has not been reflected. Now it touches the mirror here. So the second ray starts its reflection journey from here. So this is the reflected ray of the second second ray. So, and whereas this is the reflected ray of the first ray. So the reflected ray of the first ray, the reflected ray of the second ray, where do they meet? Do they meet here? Yes, isn't it? They meet here. So they meet here. So the image will form here. What type of image will it be? It is a real image, so it will be inverted. So we will be getting ourselves an inverted image like this. So image position. Now you tell me, where is the image? Remember, I told you that measurement, we start from the pole. So from here we have to look. So if we look from here, how do I address this image? Can I say beyond C? Because it is beyond C? Yes, isn't it? So the image position will be beyond C. Then size of the image. Size. Now you tell me, the height of the object, the size of the object is this much, and the size of the object and the size of the image is this much. So are they same? Definitely not. Then is the image bigger? Yes. So what should you write? Diminished or enlarged? Yes, it should be enlarged. Diminished we write for when the image is smaller than the object. Okay, here the image is enlarged, here the image is bigger, so we write enlarged. Enlarged. Then nature, what will be the nature? Real and yes, inverted. So real and inverted. Now we will now go to the fifth case, case number 5. So let's study case number 5. So case 5, object position, it will change, image position will also change, size will also change, nature will be the same, but we will write again. We will not be lazy. I will not be lazy, so you will also not be lazy. Teacher is not lazy, so student cannot be lazy. Yes or no? So let's draw the mirror. Let's draw the non-reflecting side first. Let's mark the pole and let's draw the principal axis. Now let's mark the focus. Keeping, if this is the size of the focal length, then I have to go back and I get my C. Now where will the object be in case for the object was between C and F? So where will the object be now? Next, what will be the next possible position of the object? It will be, yes, at F. Okay, it will be at F. So the object will now be at F. So let's draw the object here at F. So object position at F, which is at focus. FOCUS, okay, at focus. So let's draw two rays. Ray number 1 will follow rule number 1. So rule number 1, incident ray travels parallel to principal axis. You know what happens to this ray? After reflection, it will pass through focus. So let's get ready with this. So this is the reflected ray passing through focus. Now we will have to use another rule to draw the second ray. Which rule should I follow? Which rule did I use for this? Which rule did I use for the second ray, for the second incident ray? In this case, I used the rule number 2, isn't it? Now here unfortunately I cannot use rule number 2. You know why? Because the object is at F. You know, in rule number 2, the incident ray enters through F. So if the object is at F, then how can I make the incident ray enter through F, isn't it? So I won't be able to use rule number 2 here. But don't worry, we have still 2 more rules left, rule number 3 and rule number 4. You can use rule number 3 or you can use rule number 4. Which rule will I use? I will go for rule number 4. So what is rule number 4? In rule number 4, the incident ray enters through P, and then following the law angle I is equal to angle R, it gets reflected, isn't it? So let's use rule number 4. So it enters through P, then the reflected ray will follow angle I is equal to angle R, and it will pass through. So it will go like this. Okay. So this angle and this angle will be maintained. This angle and this angle will be same. So this is the incident ray and this is the reflected ray. So this is the reflected ray. Now the object is kept at focus. Now where will the image be formed? So you know that the image is formed where the two reflected rays meet. Look at the two reflected rays in this case. This is the first reflected ray. It's going, it passes through focus and it is heading in this direction. The second reflected ray, after touching the pole, it goes like this. Now look at the path of these two reflected rays. Will they meet? Are they going to meet? Looking at them, do you think they'll meet? No, they're not going to meet because they are parallel. These two rays are parallel, okay? They are parallel. So when you are drawing it, make sure that you get parallel line. So they are parallel. So where do parallel lines meet? I want to know. I want to know where do parallel lines meet. Who can tell me where parallel lines meet? Yes, where do parallel lines meet? Well, if at all parallel lines meet, they meet at infinity, okay? So they will meet at infinity. So they'll meet at infinity. So they'll meet at infinity. So if they meet at infinity, image will be formed at infinity. So here, the image position, it will be at infinity. Infinity. Size. What will be the size? Remember class, images which are formed at infinity are humongous. Okay, they are very, very, very big, extremely big. So remember, they are very big. So what we'll write? We'll write, should we write humongous? No. Okay, we will write highly enlarged. Okay, so the word is highly enlarged. Highly enlarged. Nature, I think I will not write. I think I'll just leave it for you. What will be the nature? Yes, real and inverted. Real and inverted. Now, the last case, we are nearing the end. We have the last case to discuss, case number 6, and this is the last case. Okay, so this is the last case, case number 6, but this is a very, very, very important case. So VVVIP. Okay, very, very, very important case. VVIC, not VVIP, VVIC. Very, very, very important case. Understood? So it's Vic. Okay, Vivik. It's Vivik. Okay, it's Vivik. So this is a very Vivik. This is the Vivik case we'll study. So image position, we'll have to change that. Size, we will have to see that. Nature, we will have to study that. So diagram, we have to correct that. Okay. So the last case, case number 6, Vivik. Object position, where will the object be? At case 5, the object has stood at F. So now where will the object stand? For the last time, okay, for the last time, the object will stand between F and P. Okay, between F and P. So object position between F and P. P means pole of the mirror. This one. Image position, we will draw the ray diagram first. So let's draw the ray diagram. Now this ray diagram is also going to be very unique. So let us draw the ray diagram. So let me draw somewhere here. Let me draw the back side. So this will be the focus, maintaining the same gap. I will draw my C. So the object position, where is the object gap? The object is between F and P. Okay, so let's draw the object between F and P. So the object will be between F and P. So let's draw the object here. This is the object. Then let's use rule number 1. So rule number 1, incident ray travels parallel to principal axis. After reflection, it will pass through focus. So okay, it did not touch the focus quite well. Let me redraw again. So okay, maybe it touched. Okay, it touched. So we'll just take this one. All right. So it has passed through focus. This is rule number 1. Now rule number 2. Okay, we will use rule number for the second ray. We will again use rule number 4. Okay. So for rule 5 and rule 6, for case 5 and case 6, I'm using rule number 4 for the second ray. So let me use rule number 4 here, which is this. We'll go like this. Now, second incident ray, this is the second ray, and then after reflection it will go like this. This is the first ray, first incident ray. After reflection it goes like this. Now if you look at the reflected ray, these are the two reflected rays, you will find that their distance is increasing and increasing and increasing. That means the gap between the distance between the two rays are increasing and increasing and increasing. So if you go down and go down, it will get bigger and bigger and bigger. So these rays are diverging further away from each other. Okay, so then where will the image be formed? Where will the image be formed? Will they be formed this side? No, these rays are going further away from each other. Here they were closer, now here they are more further away, more further away, more further away, more further away. So they are going further away from each other. So they are not going to meet here. These two rays, the two reflected rays, are never going to meet this side. They are not going to meet this side. Then where will they meet? Now, if we do a back trace of this line and this reflected ray, they appear to meet somewhere behind the mirror. Now, this area is called behind the mirror. Okay, this area where I'm placing my hands, running my hands right now. This is behind the mirror. Okay, this is behind the mirror. This area is called behind the mirror. If you do back tracing, they appear to meet behind the mirror. So what we have to do is we have to do back tracing. Okay, why? Because they appear to meet behind the mirror. Okay, so we do back tracing. So let's do back tracing. So if we back trace it, this has to be done in dotted lines. So maybe it will go like this. It has to be straight. It will have to be straight, somewhat like this. So draw this in dotted lines. Then if we do back tracing, it has to be somewhat like this. So roughly it will come out like this. So on back tracing it, we see that the two reflected rays, they appear to meet here, but this is happening behind the mirror. Okay, so they meet somewhere here. So this is the image. This is the image. Where is it formed? It is formed behind the mirror. It is formed behind the mirror. Okay, it's formed behind the mirror. So image position, just write behind the mirror. Size of the image. Look at the object and look at the image. This is the size of the object. 1, 2, almost 3 times. Okay, so what we write? Should we write highly enlarged? No, we will write enlarged. Okay, roughly the image is about 3 to 4 times the size of the object, so we'll use enlarged. So size is enlarged. And finally, nature. Interesting. So at the beginning I told you that okay, there will be one case which will be very unique from the other cases. From case 1 to case 5, we have been giving real and inverted image. Real and inverted image, remember, in mirrors, real images are formed on the same side as the object. This is also a case of real image. The object is here. Let's go to case 6. The object is here and the image is on this side. Just answer me this question. Is the image on the same side as the object? No, is it not? No. The image is the image is not on the same side as the object. The object is on the left side of the mirror and the image is on the right side of the mirror. So what type of image will this be? This is a case of virtual image. So this is virtual. And if real images are inverted, then virtual images will be correct. Virtual images will be erect. Okay, and look at this image. Is it not erect? It is erect. Okay, it is erect. This is called an erect image. The object is like this. The image is also like this. Okay, so it's called erect. Okay, erect. So this is an erect image. The object stands on the principal axis. The image also stands on the principal axis. This is what an erect image is. So virtual and erect. So remember, class, that if it is a virtual image, then it will always be erect. If it is a real image, then it will be inverted. All right. So That's it for today's class. I'll end the video from here, but before I go, I have a question for you. So the question for you today is a very simple question which we have discussed. So the question is, in which case the size of the image, let me use image, of the image is same, let me underline this word, as the size of the object. Kindly please comment your most valuable answer in the comment box and let me know. I'm definitely gonna go through your answer and I'm gonna press my precious like and give a valuable comment. Okay, so please do participate. You have to tell me the answer to this question, which is, in which case the size of the image is same as the size of the object. So which case was it? We have discussed case 1 to case 6, and in one of those cases the size of the object is equal to the size of the image. So you please kindly give your answer in the comment box. So thank you all, my dear students, for tuning in. Very soon again we will discuss, the next video will be on image formation cases by convex mirror. So thank you all once again for tuning in, and I'll see you again in the next video. Until then, take good care and God bless you all.